I'm Charles Poe,
I'm Alec Shedelbower.
and we'll be talking about the Unity and the integration with the Wolfram language. Okay. Hi. Um, Alec? Well, uh, thank you for being here. I'm Charles Poe,
I'm Alec Shedelbower.
and Jan, Jaebum, and Yacha are there. You are going to assist you during this whole session of Unity or hands-on on Unity. I think for the next 5 to 10 minutes, we are going to install UnityLink on your computer, and hopefully you all have Unity already. If you don't, we are going to help you on that. And while we are doing that, Alec will entertain us.
Okay. All right, so the agenda for the talk today, first we're gonna go over setup. Then do a quick start to see what we can do with Unity. Then do a more detailed overview of UnityLink, going through a rollball example, doing things such as creating game objects, messing with properties and components and so on. Then we'll do a quick talk about assets and then some Unity primitives. So now I think Charles should be coming around with flash drives, right? Okay.
In principle, we should have it from the page, right? On the page for the, this hands-on, you should also find the file there. So you should have the notebook for the talk as well as the file. And we have USB drive those, copy of those two files too.
Is there any way to get stuff from the web mic?
Yes, so you go to, I think it's wotcpackable.com.
Okay.
And then you find the Unity hands-on, and then you find the file there. materials. So if you click on it, you'll get the zip file. And that zip file will have the UnityLink folder. I just have to copy that Unity folder under your installation directory. So in this case, I will just go and just click on the folder and drag it there. That's pretty much it. And after that, if you do a
No mic.
link UnityLink,
Mic. Can I hear well?
oh, right. Does it matter that you need to have the version in front of the directory? Oh, okay. Rebuild backlit data. Perfect. Perfect, and it works.
And which thing did you put inside the UnityLink folder?
So if you download the file, if you download the file, you unzip it, you will get a Unity directory. You just drag that Unity directory to your Packlet directory. And you run Packlet, rebuild Packlet data. And after that, you just do a UnityLink to load it. So unfortunately, since it's still on beta and it's under development, so we kind of have to manually give you the package. So.
So can I get a raise of hands for who has it working right now? All right. Still a few people over there who still need to get it working? Almost? Okay. All right. All right. That was the hardest part. So once you have UnityLink installed, also make sure you have Unity installed. You can either go to the store webpage here or run needs UnityLink and then install Unity. Most people have Unity installed as well. So. I'm not sure. You only know it for 0.2.
Yeah, but 1.1 if 1.
It's fine? Okay. All right, so once that's installed, you can actually start. So first you'd run needs UnityLink to load the package. Let it load here. Then you'll run Unity open. This will open the Unity project selection window, which you'll see here. So from here, we're just going to go ahead and create a new project. You can name it whatever you like. Set where you want to load the project. So I'll just put it on my desktop, then hit create project. Okay, so we're going to start with a quick physics demo. We're going to have a spiky that will fall down, land on a ramp, and roll towards the camera. So you'll see now that Unity is open. So you can see the interface here. On the left, you'll have your game objects. In the center, you'll have your scene. On the right, you'll have your game object components of the currently selected game object over here. And then at the bottom here, you have your asset file or folder. All right, so we can start with some actual making a spiky in a scene. So does everyone see the presentation slide? Okay. Yeah.
Is what I wanted to actually ask. If you have the presentation slide, it should be in the same zip file.
Okay, so once you have the presentation open, if you go to this slide, you can run this first one here. This is create Unity game object. You give it a name, and then you give it some sort of geometry. Here I'm giving it the polyhedron data for spiky. So I can go ahead and run that. One second.
Should we run the initialization stuff that gets prompted for this?
Yes. That just needs UnityLink statement. One second. Sorry about that, I was on the wrong version. All right, let's try that again. All right, so call needs UnityLink. Open Unity. Create a new project, give it a name, place, and hit create project. All right, and then you should see the Wolfram Assets folder down here, and that's how you know it worked correctly. So if we go back to this slide, we can create that spiky. Now we see here it returned a game object, and it added the spiky to the scene. So you can see the spiky game object on the left over here, where you can select it. You can move it around wherever you want. Then we can go ahead, set some properties on it. So if we want to make it red, we can set the property of its material, its color property to red. Do that. Go back over here. We'll see now it's red. We can also change its position. So we can go ahead and move it up and back some. So now we see it's a little higher up here in the scene view. We can create a rigid body on it. This will make it affected by physics, so it would actually fall with gravity and interact with other objects. And then we can also set its mesh collider to convex. This is required for, yeah. Oh yeah. Did you get the presentation notebook? Okay. Yeah. All right. So once you have a rigid body, we then set the mesh collider. So we get a reference to that component using the Unity game objects function here. Then we go ahead and set the property of the mesh collider, its convex property to true. This is required for any objects that move with the collider. Let that run. Now you can see what we have over here. So we have our spiky object. If we look at its components on the right side here, we can see it has a mesh renderer, the mesh filter that contains the spiky mesh. We also have the mesh collider that's now set to convex equals true. We also have the rigid body, so now it's affected by physics. So we can go ahead and actually run this, and we should see it fall in front of the camera. And there it goes. So to make it a little more interesting, we can try and add something for it to land on. So we're going to do that by creating a plane. We're just going to call it platform. So now we have that game object here. We can look over here, and we'll see it right there in the center of our scene. Now I want to kind of resize it. So first we'll stretch it out, make it 3 times as big by changing the local scale property of that platform. There you see it's a lot bigger. And now we actually want it to be a ramp, so the spiky will roll down it. So we can actually change its rotation properties to give it a slight tilt. So now you can see it's tilted toward our camera. I'll actually make it bigger here. So now we have our spiky up in the air. We have our platform tilted towards the camera over here. We can go ahead and run that. Now we see the spiky roll towards the camera. But that's still a little boring, so we can try to line it up a little bit. So first, let's delete that one spiky we made by calling delete Unity game object and the spiky name. We can call that. We'll see our spiky now disappears. Then we want to get a reference to the light in the scene and decrease its intensity from 1 to 0.25. This will make the scene a little dimmer. Look over there. Now it's a little less bright. Now let's also create a Unity mesh for our spiky. This mesh can be reused multiple times for different game objects, so it doesn't have to create a new one every time we make a new game object. And now we have this large loop of code that will go through for 10 times right now. It will create a game object that's a spiky, give it the mesh we just made. It'll set its position to a random position at a random height. It'll set its scale to be half the size of that original spiky, and set its material to be a random color. There's kind of a lot going on here. So the initial call here uses the name in the mesh, and then there's this option called properties, where you can set all the properties you want for that game object in one call, instead of doing it line by line like we were doing before. Then the next line down here, this sets that convex property to true on the mesh collider, which is required for anything that's moving. Then we create the rigid body that will have it be able to use physics and follow with gravity. And then lastly, we'll create a light. We'll attach that light to our spiky game object, and we'll set its color to be the same color as its spiky, and change its intensity and range. So go ahead and run that. It might take a second here. Go back over here. So we should see on the left here, it should add about 10 spikies. And there they are. So if we zoom out here, it's kind of hard to make out, but you can see all the spikies are all different heights and all in slightly randomized positions. So now if we go ahead and run this, we should see something a little more interesting. Now we have colored spikies. Yeah. All right, that was a little fast, so now let's do a little bit of a slower overview of Unity. So go ahead and close Unity using this close Unity function. Then we can open up a default example called Rollerball. And that's an example data. Now it's loading that.
Do Unity open and it says fails, that it can't find the project?
Should be in the UnityLink package they're sent around. Is anyone able to open the rollerball example? No. You do not have the rollerball example on your current package, but also let's go through it so you kind of learn about how to use Unity. All right, so we can see the example here. This is just a basic game. We can go ahead and hit play. And then we'll see we have a ball that we can roll and collect these little spiky collectibles. It's a very simple game. All right, so first we'll talk about scenes. So the scenes are the 3D environments where all the game objects are contained. We can find the scene using Find Unity Scene. This will find the current scene. So here you see it found a scene called main, which is the main scene here. We can also plot all the game objects in the scene and their hierarchy graph. So here we get this graph, which represents this hierarchy in Unity right here, which you'll see on the left side. So you can see there's a parent-child hierarchy of all the game objects. So you can see here we have a parent called walls, Underneath it has the 4 different walls, north, south, east, and west. We also have the parent object collectibles, and we can see all of its different collectibles underneath it. And that's illustrated by this graph right here. All right, so do something simple like finding the position of a game object. First, you can find a game object using this find unity game object function, and just give it the name of whatever game object you want to find. Go ahead and do that. We see we found the ball. We can then grab the position using this, the brackets and then position. This will be actually the same as property value, ball, position. This is just a short form of that. Make it a little easier to type. All right, now we found position of one game object. We can go ahead and find it for all of them and do a quick plot of them to see them all. Look over here. Here we have all the positions of all game objects. So you can see the light and camera up here, all the collectibles, and the walls on the 4 edges. Now let's actually get more data, such as the meshes in the scene. So for example, we can find the mesh of a wall. So let's find the one of the east wall, which you'll see is right here. So you see it's a rectangular prism. So if we get a reference to that game object, then call its mesh component or property, that'll return the Unity mesh. And then you can use the normal function to convert the Unity mesh into the closest Wolfram language equivalent, which in this case is a mesh region. So here you see it's a cube, which is obviously not what the mesh actually was. That's because you need to apply the transform of the object. So we see every game object in Unity has a transform component, and that's how different objects are moved around the scene, scaled, and rotated. So we actually get that transform component on that wall by just calling the transform property. Then we can normalize that transformation into a transformation function. And then we can just use transformed region on that mesh with the transformation function in order to apply that function to the mesh. And now we see it's the proper rectangular prism. And we can do something similar for all the different meshes in all the scenes. So here we see the entire scene, all the mesh data within the scene. So we see the ball, the spikies, the walls, and the platform. Go back here. All right, now we can talk about components. So game objects are containers for components. As you can see over here, for example, this light has the light component on it. So we can go ahead and find the ball and then use this Unity game object components function to get all the components on a certain game object. So here we're giving it the ball, so it should find all the components on the ball. So if you look at the ball over here, we'll see that yes, all those components are on the ball. We can also get a single component. So let's say we just want to get the transform of the ball and not all of the different components. So go ahead and get the transform. You can also, instead of passing it the reference of the ball, you can just say the name of the game object, which in this case is the ball. And lastly, if you want to get all the components of a certain type in the entire scene, for example, you want to grab all the lights in the scene, you can just say all instead of giving it a certain game object, and then enter the type of component you want. So here I'll get all the lights in the scene, which it returns 2, and we see that there are these 2 lights in the scene. All right, talk more about properties now. So how do you find out about properties? So first, once you have some Unity object reference, so here I'll grab the ball again, you can do this properties property that will list all the default properties for that game object or Unity object. This is actually the same as property lists on that game object. It's just shorthand for it. Then once we have our properties, we can go ahead and get the property values by just passing in brackets the name of the property you want. So here I want the name of the ball, and it just returns the name, which is ball. This is also the same as property value, the function. This is shorthand for it. We get other things like the ball has a scene property, which will return the scene that's in. We also have some shortcut properties that make things a little easier. So instead of doing this whole Unity game object components, whenever you want to get the components on a certain game object, you can just call this components in brackets, and it will return all the components of that game object. do something similar for mesh. So mesh is not actually a property of a game object, but the mesh filter, which is a component on a game object. So when you do this, it's actually shorthand for grabbing the mesh filter component on that ball, and then grabbing the mesh property of that component. Similar thing for material. The material is actually a property of the mesh renderer. So when we grab a material, it's actually grabbing the mesh renderer component and then grabbing the material on that. All right. We also have properties for all of the transform properties. So game objects do not actually have the position, scale, and rotation on it itself. Those are properties of the transform component. But we have a shorthand, so you can just call those on the game object itself, and it'll return the transform properties. Now lastly, we have parent and children properties. So for example, we can grab one of these collectible spikies. We can grab this one here, and then we can call parent on it, and that'll return the parent collectible, which is this object here. And once we have a parent, we can grab all the children, so this should return all the collectibles. And we can go ahead and graph that here to make it a little easier to see. So here we see in red, we have the parent, and then in orange, we have all the children. All right, and lastly, we have setting properties. So once you know the Unity object with the properties and a property you want to set, you can go ahead and just do a set property, give it that object, the name of the property you want to set, and then the actual property value. So here I'm going to set the name of the ball to player. Go ahead and do that. And now when I get the property name on the ball, it's player. You can also see that over here. It might be hard to see, but it's been changed to player. We can go ahead and change that back to ball. And now it's ball again. We can also change the mesh property. For example, I'll create a Unity mesh here. That's a dodecahedron. I can set the mesh property of that ball to be that dodecahedron. So if you look over here, now it's been changed. We can also shrink that down a little bit so it fits a little better. Now it's there. Then we go ahead and delete the sphere collider on that ball, and then create a mesh collider. So now it'll actually collide with this mesh itself. Then we can set the mesh collider to be convex, because we're going to make it move. And lastly, and actually that's it. Now when we try it, it should be working with the new physics of the dodecahedron. So we can try it here. So now we can roll around as this less round shape. All right. Now let's make some more changes. Let's actually change that ball to be a spiky. So we'll create a spiky mesh, set the mesh property to be that mesh that we just created. So now we'll go back, and now see it's a spiky. We already deleted the sphere collider. We can recreate the mesh collider. So now it will be the spiky's mesh collider. I'll go ahead and do that. Set it to convex. And we also want to change the scale. All right, now we have our spiky here. We can go ahead and run it. Oh, move this. Try that again. All right, now we can roll our spiky around the scene. All right, but still a little hard to see because it's kind of gray, so let's change the colors. We do that by changing materials. So here we'll create a blue material. I'll go ahead and set the material property of that ball, or spiky, to that new blue material. So now we'll see it should be blue. Actually, let's refind it. Create this material again. All right, now it's blue. Then we can go ahead and create an orange material and set the platform to be that orange material. I can see. There we go. Find the platform, set its material to be orange. Then we go ahead and set the walls to be green. So create a green material, find all the walls, then set the material to be green. So that looks much different than the original. As one final touch, we can change the lighting and the camera a little bit. So we can find the light in the scene. We can change it from a directional light to a point light. So right now we see it's directional. Then we can set its type property to be a point. And now it's a point light. It's a little dim, so let's make it a little brighter. Let's set its intensity to 2.5. That's a little better. Then we can go ahead and get the camera game object, find its component, camera component, then set the background color to be black. Look now. So now I can play it, and we have different colors, a different mesh for the rolling spiky, and a black background. Now we can roll around. And all still works. All right, so might be wondering how the ball actually moves. So it's a pretty simple script on the ball controller. So this is actually a custom component that we wrote using C#. You can see it over here on the right. It's called ball controller. It has a few public properties. Look at it here. You can see it's a class ball controller. It has speed, an effect prefab, the rigid body, and some audio. You can see a start function, a fixed update function that actually does the movement, and an on-trigger function, which is for when it actually hits the spiky collectibles. So we'll mainly focus on the fixed update here. So we can see that Unity can get the axes for horizontal and vertical. This will automatically get the arrow keys when we press them up or down, left and right. And then we can set a movement vector using those input axes. Then we just apply that as a force multiplied by our speed variable. And then we actually see this script from the Mathematica side by finding the script asset. Back over here. Once you have the asset, we can just get the text property, and then we can see all the text for that script. All right, so that leads us to assets. These are new this year. So an asset or any of the files that are in this assets folder down here. So I'll go ahead and create a new project. Let me close the existing project. All right, open a new one. And for this, you don't need the roll ball example. We'll just be creating a new project from scratch. All right, you can go ahead and create a Unity asset by giving it a file path here. So here's assets, meshes. This will just create a folder since we don't give it any Unity object to create an asset from. So now you can see down here, add this folder called meshes. I can try to make that bigger. We can also create something like a mesh. So we can go ahead and create that Unity mesh and then create it as an asset. Give it the file path in that meshes folder and run it. And now it returns a Unity asset that is that mesh, which is in this folder. You can see it here. Now we can also do stuff like create audio clips. So we can go ahead and create an audio clip asset from the birds example data. So now it should be here. So now I can see the birds. If we have sound. We can also create materials. So we create a materials folder. Then we're going to do a loop where we create a bunch of materials of random colors and add them to that folder. I see all our materials here. And if we go over, we'll see the materials folder. And it has all our materials in it. So finding assets, we have this find Unity asset function. You can find all of them using find all. You can find them of certain types by using specifying the type here, the second argument. So here we see the spiky mesh that we made. You can also find asset at a specific file location. So we're going to find the audio file at this path. We can also find all the assets in a certain directory. So here we're going to go to this materials directory and find all the assets in it. And lastly, we can find a corresponding asset to a certain Unity object using this getUnityAsset function. So here we have our scene, and we can find the scene asset by using, should return scene asset. Oh, it's not saved yet. So if I actually save the scene, do what for Mathematica? Yeah. So for example, right now, I'll actually do it for Mathematica. So I'll have my scene. I'll call it create Unity scene, give it a name. I'll call it my scene, run that. Now we'll see it's saved over here. And then we can find that using getUnityAsset on that scene object. Now it's the actual scene asset that's in the asset folder here. Just as we can find and create stuff, we can also delete stuff. So we can delete that audio file. Now the audio's gone. We can delete the materials in the materials folder. So now we see the materials folder is empty. And we can delete a folder and all its contents. So now we just deleted the mesh folder and the mesh inside it. All right, then lastly, we have some primitives. These are also new. So primitives, Unity already has some existing 3D objects, and sometimes you might want to use those instead of loading something from Mathematica. It can be faster, and you also don't have to store extra data on the Unity side. So creating primitives, you have a create Unity and then a primitive name, where you have a sphere. Go ahead and show that here. So we can see it added sphere. We can create a custom sphere, giving a position and a radius and a name. So now we see we have this bigger sphere called my sphere. And we have a lot of different types of primitives. You have cubes, planes, if I get rid of the sphere, quads, cylinders, see cylinder here, and then capsules. And the plane and quad are very similar. The main difference being that the plane mesh has a lot more triangles, where quad just has 2. And that about sums it up. Are there any questions?
The menu items at the top of the Unity, those are doing the same thing up there as what
Very similar things, yes. These ones here, they don't actually call the Unity primitives. They call the Mathematica primitives. For example, this cuboid will actually call the cuboid in Mathematica and then move that over to Unity.
Is there a way to change the transparency of a material, either from Mathematica or from showing what's happening?
Yeah, if you actually set the alpha of the color when you set the material color property, then it will be transparent. Yeah. I think we're out of time.
Thank you. And if you have any question, we are down there on the exhibit until tomorrow. And if you are really interested to join the beta, also stop by our exhibit, and we are going to add you to the program. And if you have any questions, so thank you.